Let's just kind of work this through.
Okay, well, actually, I think there is an easy answer.
Okay.
I guess we'll discover whether it is the answer. As you pointed out before, there's actually a big hint. We know that the value function is supposed to be 0 everywhere.
Right.
And we know that the values for b, of course, are whatever. They all sum to 1, and they're between 0 and 1, and, the usual thing, their probabilities.
Yeah, it's like a vector, and the dimensionality of that vector is the number of states in the MDP.
Right, and the sum of all of them has to be 1, and blah, blah, they're non-negative. So the easiest way to get something times something to equal to 0 is to have one of those somethings be 0.
Good, okay.
So I would say that the gamma is, well, 0. It's the 0 vector.
The 0 vector, where the dimensionality of this vector, again, is the size of the state space.
Right, so I would just write 0, a capital 0. Right, that's how you usually write those things.
How do you make a 0 capital?
You make it bold, or you put a little arrow, a little vector symbol on top of it. You're drawing the Green Lantern symbol there, but okay.
It sort of happened. I didn't mean for it to happen.
Right. So the answer is 0, because 0 times something is 0.
Right. We only need one vector in that set. Whatever belief state we take the dot product with that 0 vector with is going to come out with 0. The maximum over that one vector is going to be that 0 value. This is just going to spit out 0 everywhere.
Yeah.
So do you agree that that was kind of easy?
That's pretty straightforward. Once you remember that we set the value to be equal to 0. Did we do that on purpose?
Yes. There's another thing that you could do that actually makes things work nicely also, is to say that the value of at time step 0 is whatever the immediate rewards are. That turns out to be okay as well.
Oh, and then what would the gamma need to be? 1?
No, it ends up being the reward vector.
Oh, right, because then you add them all. Yeah, that makes sense. Okay, fair enough.